Okay, so let's continue our system design. And again, I am going to talk last classes. We talked about the scalability, how we designs our system for large data set, and our system can handle a high user traffics and volume. And we have discussed we can scale our system vertically. That means whatever the server we have, we make a very big and powerful server. That means we are going to increase our CPU, increase our RAM, increase our hard disk, everything, and make one more expensive and powerful server. This is the one way vertical scaling. Another way discussion, whatever the server have, similarly we can add more server, more server, more server horizontally, and we can put one load balancer, and now request come on the load balancer, and load balancer are routing our request to the different respective servers. And we have to discuss some scalability design principle, and also discuss some natures in which context while designing system overall system and multiple component. One is your user component. Your user is handled. Some your database component where data are stored. Some where the your business processing where you are writing the your different component and microservices. So might be scalability required at the database layer, might be required at the service layer, might be required at the request handling layer. So different component, the places where you might be required to scale your applications. So today we are going to talk some techniques, scalability technique, which help us to, if you are developing applications, while development you follow these techniques, your system simply or very easy way become follow the scalability guidelines. So there are some couple of techniques whenever you are designing system that must be scalable. So as discussed, scalability means our system can handle, able to handle the large increase the user data traffics, large data, and even the large data set. Okay, large huge amount of data, and without compromising our application performance. If our one users are accessing my application, for a specific user the response should be the same fashion which previously they are working. Maybe if currently 100 user accessing my applications, what is the response? Similarly 1000 applications accessing my current application, the same kind of behavior. Maybe 10,000, maybe 100,000. So our applications, we are not going to compromise our the performance and user experience something. So those perspectives, if you're designing a system and following some of these techniques, your system can easily and simply become scalable. Okay, so a couple of points I'm going to talk about: the caching, those companies, CDN, load balancing, database sharding, and the message queuing. These are some, you can say there are lots of scalability techniques available. We are not going to cover each and everything here, but the just starting point from where you can think, yes, these techniques we should aware while designing systems. Okay, so I discussed the caching. So what do you mean by caching? Caching means if our customers are requesting, hey system, I want view my profiles, let's view profile, and again after some time they ask again view my profile, again after some time again ask view profile. So what the generally you receive the request, your whatever the microservice receive the request, do some kind of validation of your authentication, authorization, your user request, and call to the another database server. Hey database, can you give me the profile of this customer? Retrieve the profile and do some post request processing and response back. Okay, hey, this is your response. Next times again you call, again go to the next times, again get the response same time. Again next times, again go to the call third time. So for each request you are going to call remote. Maybe database is the store in the different server, different location, due to the network bandwidth, availability, remote locations, your database calls is more costlier, take some times. So is it not possible if first times I call this database and get the response, and somehow we store locally here? So store locally. So here somehow in application side you can store your data. First time call, go to the database, response, and before responding you have to update the cache and respond them. Next time next request come, you can find your cache, response data quickly. So store frequently access data in the memory to reduce load on to database and other system, whatever, maybe the database, maybe third party API, maybe different system you are interacting. So if those response, if you are stored locally, the where request landed, so that is known as a caching. And if you designing implementing system and you implemented caching, so that you cannot get any kind of a performance burdens or performance problem while scaling your system. And one thing, as let's one request come and you quickly reply them, so what happened? Now your system is ready to take another request. So you can make a room bandwidth. Hey, my system is ready to handle more and more user requests because we can quickly respond. We are not taking a couple of seconds, a millisecond to process one request. So the objective of cache, your request as quickly response, so that your systems is ready to receive more request and more request, so that you can while the basic definition of scalability, your system can handle increased user traffic. If your system is free, they can ready to receive the request and response. So while system designing, please use this caching concept where you are similar kind of request, same kind of data frequently asked by user, asked by API, asked by some systems. So instead of going to do again business processing, calling database, calling API, get output and process the data and response, why not process data, store in local area, local cache? That will increase our system performance. Whenever you are building system, sometime your application require different kind of content. Let's say you are building some UI application. UI application requires some kind of header information, sometimes HTML code, sometimes the JavaScript code. So there are sometime your application requires some kind of static codes that is maybe accessible from the different geographical location. Someone from region 1, someone from region 2, someone from region 3. So every places you are going to download these HTML resources, JavaScript, images, photographs to the every locations of the particular regions, okay, particular regions. So this will also, you can say, notice, take times. If your customers are in the different region, different continent, that will improve make the performance problem. So how to avoid? We can use the CDN, content delivery networks. So what they say, they distribute content across the multiple geographical location to reduce latency and improve the performance. So what happened, instead of you centralize all the things you have, this is the original copy, it's okay, but this is the networks for each region. This is the region, they can provide here one more sub networks, here accessibility, here that means each region they are going to access this same all their static content, HTML pages, JavaScript, the photographs, images, banner, everything on a local. So if our application get this static content from the local, it's so fast, so quickly, so you can reduce your latency. So as your centralized system is so far away, it will take time to render those images, render the pages. So it would be good you can use some kind of CDN networks where your all the static data's contents will be available your nearest location, nearest region. This help us also to make your application highly scalable and without compromising your performance. The CDN is the many places where any kind of static contents where user interact with the diagram, different kind of color, different kind of font, different kind of dynamic interaction, different kind of photograph, logo, banners, all the things are generally static contents, and that can be shipped with a different region. So one copy or a master copy should be on your server, and the same master copy can be replicated on the every regions by this network CDN. So CDN is improve your user experience. If your system is going to scale in the multiple regions, so that your user experience cannot be discarded. So maintain user experience as previously. Please use this content delivery network CDNs kind of a facility available. Maybe sometimes whenever you are going to scaling our applications, so now that means we make a multiple couple of servers, okay, so that handle the large increment load. Okay, so this is the way you can increase your servers. And now customers or user are not going to talk different server, so you are generally implement one load balancing. So all the requests come on your load balancer, one request, two requests, three requests, whatever number of requests. Now our load balancer have a lots of algorithm. They can distribute your load to equal percentage on this server, on this server, on this server, on this server, on this server. Okay, so now load balancer is the kind of inbuilt capability nowadays. Majorly cloud provider provide this facility load balancer, where you can configure I am going to distribute my loads to across the different servers, so that our each servers have a enough space, enough bandwidth available. They can receive request and response, receive request and response, receive request and response. Okay, so load balancer distribute traffic across the multiple server to improve the responsiveness and reduce the loads to the individual server. If there is no load balancers, might be every request can go to the specific server. That specific server can be crashed, cannot be responsive. So if you are using the load balancer is very light work. Just receive the request and divert it to the specific server. Now a specific server is responsible to response the data, process the data, response data. So our systems now any number of scalability increase the user traffics, our load balancer can able to distribute the load to the different server. Still they find, hey, all the servers are very occupied. They can also, hey, add auto scaling, add more server, so that our load balancer no, hey, these are the your servers are added. Now I can also distribute this load to these server as well. So please try to, for scalability, your application is very highly scalable. You can use the load balancer in your system designs. Similarly, now we discuss about the UI part, discuss about the server part. Similarly, you can database. Whenever your data are going to increase day by day, transaction by transaction, your data size is so large. Then the basic problems about the database, hey, you are firing SQL query take a times to response. If a particular table have a limited number of row, your query response very fast. If your table have a millions of record, your get query, select query take a larger time. So how to improve them? Similarly, you have to scale your data. So scale your data have a multiple way, but one of the technique is a sharding technique. What it is in sharding? Splitting data into the multiple smaller database to improve the performance and scalability. So what do you think? Instead of that, you can split multiple database 1, database 2, database 3. Now this database have a specific data they put, and you want to get from this data, get from this data, get from this data. So this is the lots of techniques. Will surely sharding is one of the big techniques. We'll talk lots of approaches, lots of way which basis you are going to split the data. Split data on the basis of region, on the basis of particular ID, on the basis of timestamps, multiple approaches where one your data you are going to split on the different. So objective is that if your database is so big and only one centralized, the problem is that you are system going to performance it. You are not, your application, your database is not responding as quick as needed. So according to, if you split data, you can put database in different location, different places, geographical location, nearest data center, so that the data can read from the nearest data center. Okay, the objective is that you can do scalability on your database side as well as from the sharding, multiple concept here, master slave, slave master, master, lots of database scaling concept is available. Later part actually will talk database scaling. Sharding is a one techniques, and master slave master, replica, lots of concept where the master node, master slave concepts in the database we are discussing. But database is also make as small so that they can quickly respond. And if you are splitting data in the multiple databases, lots of challenges come, like persistent requests go to the same database or something. Lots of challenges also database sharding have. We have to discuss in a separate section, but yeah, database layer also you can scale if your data set is going to the large, because scalability have a two kind of your system is scalable means from user perspective. Huge number of traffic can be managed, and similarly from database perspective, large data set can be managed, large data can be stored, can be processed, can be read. So only one data is might be not possible to handle your large data set. Similarly here also scaling can be vertical, scaling can be horizontal, you can apply. So whatever the places here where you need the scaling, that means you can go with the vertical, we can go with the horizontal, depend upon the nature of data you are going to, depend upon your cost, depend upon your use cases. Sometimes you can also think, whenever you are designing systems, and might be you have designs your system in the multiple component, and the components might be need to communicate to each other. So there are multiple way. Maybe this component microservice one directly communicate to another microservice. So this is known as a very synchronous communications. Might be until you talk to them, until they are not responding, your service is waiting for the responding to the again from where they receive the request. So another way you can use kind of asynchronous communication between the different microservices or different components. Okay, so one way you can use the message queue. So message queue is the kind of queue. Hey, they want to talk to the here, they are not going to talk directly here. They say, hey, process this record. They just one event here generated, and this is also subscribed somehow. Hey, this is the event some they receive. Once the activity done, they can also publish my, hey, I am done. So now another reader, hey, it is done, then they can give the proper response. So somehow one microservice generates some event on the queue, and another microservice read from queue, and once done again response them. So in this way, these two microservices are decoupled. They are communicated to each other, but asynchronous fashion. So here use messages queue to handle asynchronous requests and reduce the load on the individual component. And in this way, multiple systems can interact. So messaging queue also have a different kind of messaging queue. We have to talk in the separate session. Messaging queue may be topic, maybe queue, multiple approaches, but messaging queue nowadays one of the concept where two microservices, two components are communicate, are related to each other with a very loose couple. So here also example of loose couple and asynchronous. This both concept make our service more scalable. Now we can add more server, we can add more server, we can add more server. They are not tightly coupled with them because they are directly communicate to their middleware messages queue. Okay, and might be you can increase the messages, you can scale your multiple Kafka key, multiple messages if you think, right? So somehow messages queue is the concept which help us to make all the components are loosely coupled and they are communicate to each other via asynchronous method. What this help us, so that your now what the benefits, if this microservice are not is going to our maybe different microservice, just make one call, hey, this is my queue, I want to get data from here, and this will read the data, you are read, hey, does I done processing done, then again this read. So now once they pass the message in the queue, after that this server, these services are ready to receive another request, another request. So as our any services are available free, they are ready to take or entertain a new request. If they are blocked, they are waiting, they are not going to respond, or they are not going to take or entertain the new request. So the objective is that why we are using the loose coupling or asynchronous, because our system is more in a position they can handle the multiple requests as possible. So as they respond quickly, they have enough bandwidth to take another request, take another request, take another request. So it will easily, if you design system that can easily scalable. And that's lots of techniques, but it's a couple of things we discuss. But ensure that whenever you are going to design your application, please keep in mind that your application can be scaled vertically and horizontally. While scaling, you cannot lose your performance, reliability, and user experience. For these, you have to implement some additional concept like a caching, like a CDN, like asynchronous programming, messages queue, loose coupling, load balancer. These are the technologies, these are techniques help us your system say, hey, now our system is very, very scalable systems. This is not only techniques, dozen of techniques available, but let's you start from this, and once you're done, you can go more and more. So let's talk a couple of tools and technology which help us to meet this. Let's you want to implement caching, let's you want to implement the load balancing, you want to messages queue or something. So for that, you are not going to design, invent something. Already we have a tools and technology in the market exist, just we have to select and use them. So a couple of cloud services provider, container orchestration, load balancing tool, caching tool, monitoring and logging tool. These dozen of tools and technology exist for build, designs, scalable applications. So I'm going to talk couple of, but this is not the only. So first and major, if you want your system is highly scalable, just use the cloud service provider services like AWS. Provide your system can be easily scalable, just follow them. Or maybe talk Microsoft Azure, or you can take the help of the Googles. They are provide the automate the deployment and scaling of your cloud resources. Cloud resources here might be your microservices, might be your database, might be your load balancer, might be your cache server, everything. All the cloud resources, if you are using our cloud provider is providing the benefit, you can just configure them, ask them, they provide scalable facility to you. Now your system is more scalable, and nowadays almost major applications are using the cloud provided services for scalability. I'm going to talk couple of examples where you can find cloud service provider play a very important role if you want to design a system that is highly scalable. Couple of use case scenario we're going to discuss, but think this is the very key and important part. If possible, discuss with the customer. If possible, customer is ready to use and build cloud provided services for scalability, let's use them. Similarly, sometime you want to your own set of machines, you can create own nodes and you want to all the manage, you can use Docker help us to create a lots of small containers machines, and you can deploy, you can say scale out, scale in, vertical scaling, horizontal scaling you can do from your Dockers, and how to manage all the Docker containers, Docker machines, just using the Kubernetes manage everything to provide your automate the deployment, scaling and management of the containerized application. Means one container application might be microservice, one container application, but database one container application for the front end applications. So whatever applications you are running on different container, containerized OS, containerized server, and these all the things. If many places I also works where we are using Docker and Kubernetes to manage our cluster. We are not saying, hey, cloud provider, one of the options you can use the cloud provider services, or if you say, hey, cloud provider, just give me the plain machine, we will manage our node, we will know how to decide our scalability. So for that we can use the Kubernetes and Docker both combined and help us to meet the very easy deployment scalability of your containerized applications. So please you should aware how Docker, how maybe lots of other open source software available. Okay, so try to use container orchestration tool like Kubernetes, like Dockers. Similarly, if you planning to use my load balancing, so you are not going to write your design system how I implement load balancing. Just try to use, already in the market have a tool like HA proxy is available. Just you can integrate this HA proxy and define your rules and regulation on which parameter based, percentage based, load basis, key basis, ID basis, region basis, what the parameter on which base our HA proxy as a load balancer going to distribute your load across the different server. Or maybe you can nginx, or you can use the again cloud provider services like Amazon, AWS, Google, Microsoft. They have a ELB, elastic load balance. They distributes traffic across the multiple server to improve the responsiveness and availability of server. So if you are using the cloud provided services, they provide the load balancer. Just you can use them, or you can use the open source or the provided. But now you should don't think this is a very complex. Just try to understand these kind of tools available, open source and non-open source. Just we have to use them so that my application is more scalable. All the tools, whatever I am talking here, HA proxy or real, they provide the configuration according to your requirement. They can configure, and the load balancer is work for your needs. Similarly, we discuss a technique. We need to implement caching. So we are not going to write my own code how to implement cache. You read data from here, how to cache them, again response them, what the cache problem. So already in build market, cache server available for us. Just use the Redis is the most famous, or use the Memcache, maybe Apache. Lots of caching server tools, software available. Some are the open source, some are non-open source. If you can use, so application automatically improve the application performance and reducing the number of requests made by underlying system. So they are also reduced, not go to the call database multiple region many times for the specific requests, one time or two times sufficient. Okay, so caching tools already available. How to implement? Just use them tools. And if any tools, maybe you can write Redis have already well documented how you can use them, how can consume them, how can start, how can configure them. You want to use the Memcache, you can use the Memcache. So lots of open source as well as the cloud provided cache mechanism also available. You can use them. Similarly, what happened if your request is handled by the load balancer? A load balancer have a diverting your request to the couple of nodes, maybe nodes or lots of node servers available. Okay, so lots of Docker instances available. So whenever your number of instances of the Docker are going to increase, the new work come to manage them. Hey, this node is healthy, they are properly taking requests, properly responding, is there is no memory outage, CPU is balance, many problem with the row, every node you have to monitor them. So for that we have to, hey, how many number of average this server are getting requests, what are the response time, what are the average response time, what are the maximum time, what are the minimum times, lots kind of stats you need to monitor all the your servers, all the network they are distributing their loads, right? So for that we are not going to again think from a screen. Hey, you just think for this scenario already lots of tools and techniques available in the market, like you can use Prometheus, they help us API level, method level. Hey, the particular methods or particular API call by how many number of times, what are the average time, what are the maximum response time, what are the minimum response times, method level, class level, API level, everything you can track. Just include this Prometheus, or you can use the Grafana help us to know, hey, what are the logs generated by this server, logs generated by this server, this server, this server, how to track the particular problems, debug the problem, logs generated by this, they are going to integrate it in the Grafana. Grafana provide the consolidated view to your application. Similarly, you can use the tool like Elasticsearch, Logstash, and Kibana. They help us to visualize tools. Hey, here you can run visualization query and form. You can just all the logs received from the Grafana you can store somewhere, and they provide the historical data to you. Hey, what are the failure, success, and lots of things. So you can lots of the market tool available which provide us the real time insight into the application performance and scalability. Once you scaling your application, you need to monitor and log checks health status, memory, CPU, everything. These tools help us so that we as a system engineer should aware, hey, our system is in a healthy state. Hey, some server is going to very load, let's increase some more server, or maybe replace with a new server, can be change something, so you know something. So these are the lots of techniques you can say where you can think tools, technology available in the market. We have to just explore those tools and technology. Okay, let's talk about the use cases where this scalable application in the nowadays. If you talk about the near about all the applications you are using, mostly they are built as a scalable architectures. Scalable architecture means your application, these applications can easily scale up, scale down. Good example, you talk about the Netflix. Netflix is a scalable architecture which uses the combination of cloud services, microservices, and caching. Now they are using lots of cloud service provider services, microservices architectures, and caching to handle high traffics. If you talk Amazon itself, no, Amazon e-commerce application, e-commerce platform. This is the scalable application platform which again use the combinations of cloud services, because Amazon itself cloud service provider. They have used lots of services to maybe load balancing, or maybe your cache management, everything. They are used by the, even talk about Google search engine. Google search engine also is a scalable application. They are using the distributed indexing, caching, load balancing to handle the large traffics to the search engine. So if you talk Facebook also is scalable applications to scaling, to handling huge number of user traffics. They are scalable application. The Facebook also use the your lots of cloud service provided architectures, and even the microservice architecture, means the caching, everything they are using. And even talk about some other lots these you can say scalable architecture. And nowadays if things where your applications is available for across the geolocation, that must be in scalable architecture. If you talk about Twitter is also a scalable real-time messaging platform. They are also using the distributed database, caching, load balancing to handle the high traffic something. Similarly, talk about the Dropbox also is a scalable file sharing platforms, which is use a combination of cloud storage. Now they are using the cloud storage, cloud caching, load balancing, and handle the huge traffics. Even we talked about the Instagram also is scalable application for photo and video sharing platform, and they also use the lots of cloud provided services for the caching, load balancing, high traffic. So you can say, look the near about, and whatever the applications you are using, generally they are built as a the concept of scalable architectures. A scalable architecture simple means your system is now capable handle to any number of requests. If user request is increasing, your system should be response properly handle. User experience cannot be violated, user performance is not violated. So is it possible to just scale your application, just scale out one more server, 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 one more server. I scalability at the different component level, microservice level, database layer, front end layer, static content layer, implement caching, everything. So if are using these things, you can take even let's take if you talk about the scalable architecture, just Google Netflix, Google, Dropbox, Facebook, Instagram, all the scalable architecture available for you as a reference point. Just you look them, just you search, hey, what is the Netflix scalable architecture? Look them, how they design, whatever things we are talking, they are using actually. So let's I'm show the demo. Already I have searched this Netflix system design architecture, and if you look here, these are the high level system designs they implemented. Here notice they are providing such a, this is the very high level architectures, right? So notice here lots of user interface they had. Now they are using here the load balancing, elastic load balancing. Here they are using the CDN, open connect, look like content delivery networks. Oh, this Netflix uses own content delivery networks like CDN, similarly for your video, for audio, everything, right? So similarly they have here registry, lots of your notice here the MySQL database, a different kind of here Amazon services they are used. They are using the queue, Kafka queue, the multiple Kafka queue for analytic streaming. Similarly they are using the queue, make the asynchronous communication within the transcoder and a video, whatever the video you are uploading on the Netflix, they are converting in the multiple format and using the transcoder. They are not the synchronous communication. So lots of techniques and tools for notice here the cache service, here the different NoSQL database, here the Cassandra database. So cache server they are using. So just use, they are using the lots of tools and technology in applications. When we talk, this is the open connect, this is the again content delivery network, global custom, this is the Netflix custom global content delivery networks that's used. Okay, similarly if you talk about the backend architecture, similarly they can use the AWS elastic load balancing a load. After that go to API gateway call the multiple server. Now they are talking multiple microservices because the scalable multiple instances of microservices running. They are talk to the database, they are to the cache, they are implementing the cache as well as now they are using the for analytics. They are using some queue, messaging queue. They are just pull data in the pipeline, and pipeline going to again store in the S3 or Hadoop well. So lots of reference document available for you if you took here how the backend response to the open connect as a CDN networks. Similarly, just look, this is the how API gateway they are designed, different region, different security group, how our elastic load balancers support kind of a different kind of security group, so that your networks, your servers are under the secure guidelines, right? Similarly you can look how they are internally handle lots of kind of filtering, different kind of filters, lots of designs, API, how your API gateway implemented, multiple instance of one microservices, different microservices, how the particular routing happen in the different servers they are using. So you can just explore, like here, if we are implementing the API gateway and multiple service APC, particular down fallback, what with the response, how the new server will come. So lots of techniques, this Netflix architecture you have. Just notice here, cache server implemented. Hey, any web requests come, they are going to the, hey, take from the cache server. If cache data get, it's a response. If not get, then go to the, again, similar kind of services, dummy response something, similar services have, then response, and go to the database, again update the cache, again to the similar response. So lots of designs here available. You can just explore anyone, Netflix, Google, Amazon, they are using the Apache Cassandra database. Why they are using NoSQL? Even they are using the SQL as well as lots of things they are written here. Just you can use here. The notice there they are using here like a load balancer for HA proxy, then somehow S3 database and Hadoop as well as some queue as well as some different router as well as Kafka for consuming. So notice the big scalable applications are not just depend on one technology, one database, one techniques. You can use the Apache, the Spark for streaming, for analyzing data. For similar, notice here they are using Elasticsearch for log and monitoring. They are using Elasticsearch as well as for logging monitoring system for visualization. For so you can say lots of things they are using, which we discuss. So similarly, these all are kind of a use cases where currently bigger players already build the scalable systems. Okay, and scalable, while building a scalable system, they are using lots of open source software, lots of cloud provided software, lots of techniques, lots of designs. So if we see these reference architects, these known as a reference architecture. I am receiving some customer requirement, and the customer say, hey, you want to build a scalable architecture, a scalable application. So these all Netflix, Google, Amazon, Dropbox, Twitter, Facebook, Instagram, these already you have a reference document available, reference architecture available. You can study all them, and you find for the particular huge number of user requests come, how we can apply load balancer, how we can apply API gateway, why need a database sharding, why need a caching. All the things already implemented, all the which kind of open source software, paid software available. Just explore them, and after studying this reference document, then you can design your system. You can quickly design the scalable system, and with the help of your existing knowledge. These all the systems which are running Facebook, Instagram, LinkedIn, Twitter, they have available your reference scalable architecture. Just Google it, find out, understand, and then think how we can design the system. They help us. You can say these are the knowledge base for you. If really you want to design the system scalable, then use them. But not surely the same, but according to your use case. Might be some where customers say, hey, here I don't want to go the paid software, I want to the freeware software. You can explore alternative freeware. So for each places, for implementing load balancing, implementing caching, implementing API gateway, implementing database scalable, implementing sharding, implementing caching, implementing everything. For everything, you find somehow open source tools and technology, somehow cloud provided source and technology. Let's explore which things is fit suit for you, and let's use them. So system designing is a kind of a very broad thinking, not just think the customer requirement which customer have. This is the very important, but this is not the only important. Apart from that, you have to take the help of lots of reference architectures. This reference architecture make the confidence, yes, I can design this problem, this requirement for this customer with the success ratio. Okay, so use this reference document, reference architecture, and designs your system that can handle large increased amount of traffic load, and those scenario your system should be scalable. If might be some system, some application that not required scalability, one application, one database sufficient. So this is depend upon your use case, depend upon your requirement. No thumb rule, always you can design your system as scalable architecture. No, let's first discuss customer requirement. What customer really needs such large volume of applications, large volume of requests, large volume of data? Might be customer not needed. So why unnecessary you are going to implement each and everything, like you design application as a microservice architecture, as a scalability, API gateway, everything. These are the good terms, but these are tool used for a specific use case, a specific scenario. This is not for every system design. Be ensure whatever the tools and technique learning, everything you cannot apply in your system design. Please be clear. All are the different tool. Just understand the customer problem, customer situation. If customer really might be not needed any kind of scalable application, just go with a simple monolith application. One server, one database is sufficient to serve the business. Finally, you have to earn business. If customer less number of user base, less number of requests, less number of data, why need a scalable application? Not needed. Our simple standalone application is sufficient. Okay, so everything, whatever we are studying in designing, don't keep in mind everything we are going to use. No, all are the toolbox of system designing. Whenever you are designing system, think which tool is fit. Maybe standalone simple application is fit for the customer. Let's go. Maybe not needed distribution file system, not needed. Might be not required the cloud. Might be not required the something highly available system. Okay, so please be focused on your customer requirement. If your customer requirement really this, then you can go design such a system. Because nowadays the system you are looking like Netflix, Facebook, Instagram, these are the very big player and company. Might be you and we such engineer are not going to design such a big system designs. Might be in a real life you will not get a chance to design system such like a such scalable system. Might be your client is very small, customer is very focused, customer is very specific region, a specific language, a specific location. Your system is simple, monolithic, work fine. Somewhere microservice architecture fine, somewhere high availability fine, somewhere high load is fine. So just these all the system, due to that system designable, lots of tools, technique, instruments these have. We are learning all the things. That not meaning we are going to apply everything in one system. No. Be keep in mind, focus on the customer requirement. According to customer requirement, we have to use this system design tool. These are just system designs tool. Scalability is the one tool. Availability is the one tool. Fault tolerance is the one tool. Sharding is the one tool. Lots of tools are there. Sometimes you need a one tool. Sometimes you need a two tool. Sometimes you need a 10 tool. The tools are used for the use cases. Hope this makes sense. Everything, whatever you are studying, is the one tool. Let's learn them. You should aware. And might be good a chance you are going to work such a high big company and you have to get a opportunity to design such systems. So this reference document, reference architecture help you, and you can design, you can work. Even on the top of that, you can think more. All these designs are evolved on the cases of use cases. If you talk 20, 30 decade year ago, might be such systems we are not building because there is no such infrastructure available. There is no such requirement available. But nowadays we are building such application. Why? Because nowadays we have an infrastructure, we have a tools, we have a technique. Why? Because such use cases we are generated. So if you talk about Netflix or something, anyway, or LinkedIn, depend upon the use case. They designs a new system. Might be scenario where you are working, where some different kind of use case come, where you design something drastically new system, new concept, new technology, new principle. So these all are the technique, tools, and principle are not just fixed. In future, you can invent new algorithm, new way to handle the customer load. Please feel free to open. These are the things you should aware. That's help us to think more beyond. System design is just not copy paste and do. Just think on the top of that what you have. These are the helping tools. Tool is not work itself. You engineer need to decide which tool, which place I am going to use. Might be I need the particular use case scenario where no tools are fitting. Whatever the design tool we have studied, no tools are fitting here. So that not make we cannot design a system. We can also design a system where no tool is, whatever the system design tool we studied that not fit. You can think we have lots of learning, we have lots of knowledge. Using this knowledge, you can design a new technique, new principle, new way, new concept in the system design. Okay, all the things is for just reference. Please feel free to discuss customer needs. If customer needs, let's go. Not need, don't go. There is no any fashion or your curiosity. Okay, I know everything, then I can use. No. Focus on customer requirements. Hope this information helpful you. Thank you for watching this.